Okay, so we're going to take a look at a more advanced way to use lists in managing our apples in our scene here. Now, if you think about it, apples belong to this apple class. Now, wouldn't it be great to have some way of referring to the apple class as a whole, to say something about all the apples that are on the screen, not just individual apples? And with classes, you can do that. You can have things that are common to all instances of that class. So say all apples should know how to destroy all apples, or all apples should know about the apple list, that sort of thing. All right. Now, the way that we do this is through the use of the static decoration, the static declarator here, right? So we'll take a look at our Apple script. Now, say we want to have a script that is specific to apples. So here in our Apple prefab, if we look at Apple Tree prefabs, red apple, okay, here we're looking at the red apple prefab. I've already gone ahead and I've assigned this apple behavior script to that apple. Okay, it's just like any other script. Okay, and if I open it up, you'll see here is my Apple script. Now, the most exciting thing about this right now is that I'm using something called static to have things that are common among all apples in the class. Okay, so each apple will have its own update function. So there's nothing unusual here, void update. Each apple is going to have its own OnEnable and OnDisable function, and those are some methods that are built in just like update. Right? So when an object gets enabled or an object gets disabled, the appropriate version of that will happen, for each of the apples. Right? So in this case, when an apple is enabled, it will add itself to this something called AppleList. And when it gets disabled, it will remove itself from that same Apple list. Okay, it removes the game object that it is associated with from that list. Now, what is this list? What is this Apple list that we're referring to? Well, the Apple list is here. It's something that gets set up, but it gets set up as a static, public static list. And that static there means that this list is shared among all instances of apples. It only gets called once when the class, and Unity does this for us. Unity says, okay, if I have a static method in a class, it only gets called once. Now, tell you the truth, I'm not sure what will happen if you try to do odd things like, say, static update. I don't think that's going to work. And anything that an instance needs to know about or gets created as part of an instance that's not static, you can only use static things inside of static functions, right? So you'll notice here, after I have this public static list, Apple list, and so on, I also have a static function here. Static function, public static void destroy all apples. And what that means is that all apples can refer to this same destroy all apples, right? So that means everything in there has to stand alone from any particular instance of the apple class, right? Now, the other cool thing about this, because I've declared it to be public, this is something that all other scripts can refer to by saying apple behavior dot destroy all apples, right? Because it belongs to the class, not a particular object or component that uses that class, right? So I have my public static void destroy all apples now, and what destroy all apples does is it destroys all the apples, right? And it uses the list to do that. So one of the things that we talked about a little bit in terms of using for each, anytime you use for each on a collection, you have to be careful, because if you modify that collection, if you modify the members, like the makeup of that collection, who's in that collection, you really can't do that inside of for each, because the for each likes to keep track of that class, or all the members of that collection. Now, one way around that, the simplest way around that I find, is that what I like to do is, the first thing, if I'm going to be modifying a collection, what I do is I make a copy. I say, okay, list GameObject temp. I make a temp copy of that list, and I copy that Apple list to this temporary list. Okay, so now I can remove apples or remove GameObjects from the actual Apple list, or I can modify them without getting in the way of the list that I'm actually working on, right? So I'm working on the temporary list while modifying the actual list, right? Now you might be looking at this code and say, well, okay, I don't see you actually modifying the list here. I just see you destroying the apples. So where is this? Where's the modification of the list happening that you're avoiding? And the answer to that is, well, by destroying an apple, that effectively is going to cause its OnDisable function to get called as part of this destruction, right? Destroying an apple removes that game object from the scene. And this OnDisable, that is where it is actually removing the game object from the list. So even though I don't explicitly say remove up here, effectively it's going to call this, right? So that's why I still have to be careful in that same way. So that's why I create a copy of the list, the master Apple list to a temporary, right? That's what I'm doing there. And now iterate through the temporary list. That's the important part. And ultimately here, destroy each apple. Okay. Now you'll notice if you're looking ahead, you're curious, you're saying to yourself, well, what is this down here? You know, is there a cleaner way to do this? Now, I want to mention this. Alternatively, there is another feature, this link feature, which you can use. It's basically sort of another extension to some of our collections here. We could say using system.link, right? In which it sort of extends some of the features of our list, and it allows you to do this. Instead of saying for each GameObject tApple in temp, you can sort of automatically create, see it has this extension to automatically take one list, convert it to another list, or copy it to another list, right? So if you are familiar with link, you could have in fact said for each GameObject tApple in mappleList.toList, and that would have just avoided creating this temporary. So we could have avoided this step here, and then instead of doing this, we would have said in mappleLists to list there. Okay. Now this is very cool because now, okay, remember our scene manager. If you remember our scene manager script over here, and we'll go back to our scene. And I'm not sure what caused that bling sound, but anyway, in our scene builder, we used to keep track of all sorts of things here and create a list of apples in the scene builder, and then sometimes that's still okay. You know, sometimes you want a scene that contains all of the objects that you're building. In this case, not really necessary. Okay, so here I've removed this public list of apples, and I no longer add them to the list, and I no longer handle the destruction of all the apples directly here. And instead, I alluded to this before, I mentioned this before, I can now refer to the Apple class, the Apple behavior class, excuse me, and just say Apple behavior dot destroy all apples. So if there is a static method of that class, I just use the name of that class, and then I can refer to the method on that class. Right? So I can remove all of this. I just temporarily commented out, but so all of the Apple list management stuff over here can be removed in favor of just calling it as part of that bushel of apples, right? So that this class is now taking care of all of the apples, and then everything works just as you think it would. Okay, destroy the apples, and they get destroyed, right? So you'll notice all the apples, even the red and green apple up there. Oh, the green one didn't. I must not have changed that in my code. Let's see. Let's try that again. And destroy all apples. All the red ones did. The green one didn't. Why didn't the green one? Okay, here's the green apple. And you'll notice the green apple at this point does not have that class on it, that component. So if I wanted to, I could just simply say, okay, now that green apple has that component on it, so it will add itself automatically OnEnable, OnDisable as part of that list, part of that class. It's using that class, so now it's a member of that collection automatically. Ready? Boom. It gets deleted as well. Nice, right? Okay, the other thing you might be noticing, and this is a good thing for the project, you'll see all of the apples there, at least all of those that crossed that line, they destroyed themselves. They disappeared. These guys didn't, right? But all of the ones down here disappeared. Now, why did they disappear? Well, we added a behavior to the apple, right? And this is part of its normal update. So this is independent for each apple. It has this. This is an instance method, right? And it said simply, it said if transform.position y is less than -3, so it crossed this boundary of -3 on the screen. If that happened, destroy that apple. Okay, so if we looked at our main camera, we zoom in and we see, okay, -1, -2, -3, which is about halfway through the chest here. That's -3. So the moment the apples cross that line, their transform will have changed to be less than -3. And in doing so, then it will say, okay, it is time to destroy ourselves. Okay, so let's watch it happen here. Right about here, boom, they disappear, right? Because their transform .y here will have decreased due to gravity. It will have dropped, it will cross that boundary, and it will get destroyed. Okay, so there's a couple of things for you. It's kind of some advanced list management and the use of sort of monitoring our transform.position and triggering a behavior or doing something based on this apple behavior here inside of update. Right? Update is continuously called once per frame. So it's checking once per frame. Has this apple, since this is a instance method here, you don't see static in front of it, right? If this instance method is getting called for that particular apple, right? So you have these instance methods and you have these static, which are basically class methods that are shared across all instances of that class, whereas these are one per, right? That's why I can refer to a specific position. I couldn't refer to transform.position up here. And if I tried that, I think it'll just barf at me here. Transform. See, it'll only allow me to use the capital version. It's a type. I can use that, but I cannot use the lowercase transform there. Whereas in here, it's okay. I can use that because this is an instance method. Right? All right, that's enough for now. Let's see. Nice little lesson. And also a test of our new capture method here.